Let's go ahead and have a look at Demo 1. Connect the Wi-Fi module and access the LAN. In the first demo for this lecture, I'm going to show you how to do the connections between the Wi-Fi module and the Arduino. And then test it to make sure it all works before we move on to do something more useful in demos 2 and 3. So when you get your Wi-Fi module from Adafruit, it's going to look like this, with the exception of the headers. So the headers will not be attached. You're going to have to solder them on. It takes about 10 minutes. Just be careful not to burn anything. Now, once you have your headers on, you can go ahead and do the wiring with the Arduino. The Wi-Fi module uses the SPI communications interface, which is very similar to, it's identical to the way that we connected the SD card module to the Arduino in a previous lecture. One difference there is, though, here that we are now using an additional 2 pins that I'm going to talk about in a minute. So before I actually plug it in, let's have a look at the documentation. So if you go to the Adafruit website, there is a document, so the Adafruit CC3000 Wi-Fi PDF document, and I've got a link to this document in the notes. And it's quite extensive, it's well documented, and it contains the pinouts. That's in page, I believe it's page 30. 15, page 15. So it's got the pinouts. It tells you how to connect the module to the Arduino. However, I think that my notes are better. So also in the lecture notes, you can find my PDF document that shows you how to do the connections between the module and the Arduino Uno specifically. In this simple to use table. So remember from the SD card lecture, the system clock pin, it's got MISO, so master in, slave out, MOSI, master out, slave in, the chip select pin, which for the Arduino Uno is flexible. We can set it to whatever we want. I set it to 10 so that all the pins are nicely tucked together. Now the last two, VBN and IRQ, were not used when we did the SD card demos. We haven't seen this before. So I'll talk a little bit about the IRQ first. So IRQ stands for interrupt request. The idea here is that because the Wi-Fi module receives data from its from the Wi-Fi network at any time, without the Arduino necessarily knowing about it beforehand, we need a way for the module to let the Arduino know that there is data to be read. So the Arduino then is going to raise the IRQ line and therefore notify the Arduino that there is data to be read. The Arduino will stop doing what it's doing at that point in time and start running a routine that is going to handle this interrupt request. Essentially, it's going to go and get the data that the Wi-Fi module has available for it. And once that transaction completes, then the Arduino is going to get out of this interrupt request function and continue doing what it was doing before the interrupt happened. So this is a hardware interrupt, and for the Arduino Uno specifically, you must use pin number 3. So that is digital pin number 3. The VBN or enable pin, we set it to Arduino module, digital pin 5, is a way for the Arduino to reset the Wi-Fi module and essentially turn it on. So we do have the voltage, so the positive reference voltage in VIN pin. So this is this red line here. It just provides power to the Wi-Fi module. The Arduino still needs another way to turn it on, right? To reset it, make it ready for use, and that is digital pin 5, VB enable. and you just also plug ground as normal. So these are the pinouts that you need to use. I've already done the wiring on the mini breadboard, so I'm going to just plug in the Wi-Fi module. I'll plug it in. Next thing we'll do is to install the library that we need in order to drive the Wi-Fi module. So Adafruit has got a GitHub account, and this is the location from where you can get the library for the CC3000 module. When you feel comfortable with C programs, you can have a look inside those files and see how the functionality that we use in our sketches is actually implemented. But for now, just click on this button to download the zip file, then extract the file and install it into your libraries folder for your IDE. So I've already done that. So here's my libraries folder, and inside it I've got the Adafruit CC3000 library with its examples. So restart the IDE, and let's have a look at the first sketch. Now the first sketch that I have here is one of the examples that come with the libraries from Adafruit, with a library from Adafruit. So to get it, go to examples, look for the Adafruit CC3000 library and click on build test. It's going to bring up the sample sketch. The only thing really that you need to modify here or to check are, first of all, that the connections are correct, so that the IQ has been set to number 3, VBAT or VBN, for enable, is set to 5, and that your chip select is 10. That's one thing to check. The other thing to check are the credentials for your Wi-Fi network. So these are the credentials for my Wi-Fi network. Change yours to fit your network. We're going to have a look at the rest of the contents of this sketch in a minute. Okay, let's now upload sketch and make sure that we can connect to the Wi-Fi network before continuing with demos 2 and 3. Alright, initializing the device, check the firmware version and its MAC address, scan for networks nearby. Attempt to connect to my Wi-Fi network. Connected. Right, so here's the parameters of the network connection that the board got from the DHCP server, and that's all there is to it. Pinged Adafruit as well, did the address name resolution, sent out a ping, 5 replies came back, it all looks good. So we do get a successful connection, so let's have a look at the sketch and what's in it and how it works. So we start with a few inclusions. The first one is to include the Adafruit library. The second one is just a library that contains helper functions for the SPI library, which comes in next. We've got string class to help us out with strings, plus a debug file that contains some additional helper functions that are used further down in this sketch. Next, we're defining the pins we're going to use for the IQ, VBAT, and chip select. Then we'll create the object that represents the device. So this is the constructor, and we pass those the values that were declared earlier. So the chip select, IQ, VBAT, and the last one, the SPI clock divider, is a parameter that tells the the board, what frequency it should be working on, and this really depends on the Arduino that you're using. So it will be different. This value will be different on an Arduino Uno versus say an Arduino Mega, but it's not something you have to worry about because the library is going to detect which board you're using and automatically set this constant to the right value. So then we've got the credentials for your network, the name of the network and the password. Next on is the type of security that you're using, and this board in the library covers most types of Wi-Fi security that is used these days. In my case, I use WPA Personal 2, so I set it like that. Moving on. In the setup function, set the speed of the serial port at 115,000 baud. Send out a welcome message, and then display driver mode. So there's a function down towards the bottom. See if I can find it. Here it is, display driver mode, and it tells us if we are using the tiny driver. So the tiny mode is a mode that you can load the CC3000 library in so that it occupies as little memory as possible, which is good if you're using microcontrollers that just don't have enough RAM or static memory or flash memory. So then you can just load that load the driver in tiny mode. In the notes I explain how to do this. It's pretty easy. Otherwise, we've loaded up the full driver, and we can get some parameters out. So the buffer side, for example, for the receiver, and the buffer side for the transmitter. Right, so moving on with the setup function, we'll print out how much available RAM we have, which is a good function to remember, especially when you are debugging your programs. Sometimes there are issues with memory, especially running out of memory after multiple loops. So if you want to know if your program has got what's called a memory leak, which means that objects occupying memory and never being removed after the end of a loop, eventually exhausting the available RAM, then by using this function, get free RAM, you can find out if that actually is happening. And we use the begin function on the CC3000 object, the object that represents the Wi-Fi device, and we basically start it up. Check the firmware version. Again, further down, that's not so important, but further down you'll see that there is a function that reports the firmware version. So firmware is the software that runs inside the Wi-Fi controller inside this chip. And this is created by and written by Texas Instruments. You can't really do much with this firmware in terms of upgrading it to newer versions unless you have the right tools. So obviously it's not something that we cover here. Then you display the MAC address. This is interesting. Let's have a look how that's done. Right. So here's display MAC address function, and in here there is a call to function get MAC address. You pass a reference to an array of bytes, 8 bits each. So this is what this data type is. It's an unsigned, that's what the U stands for, integer that has 8 bits, so a single byte. And like this, we declare a array of 6 of these unsigned bytes. So then we pass a reference to this function, and then this function is going to use this reference to store the MAC address from the device to this memory location. So then we can print it out like this. So this function, print hex, will look at the memory location at MAC address and the 6 bytes that follow that particular address, convert each one of those bytes into its hexadecimal notation, and then print it out. Now remember that I showed you the GitHub account for Adafruit, which is right here. So if you go to CC3000 CPP, the C++ implementation of the driver, then what you can do for the curious of you is to copy and then look for the implementation of this function, and this is what you get. So this is how the printout is generated, the hexadecimal notation of the MAC address for the device. Don't worry if you don't understand any of this. I'm just showing you that it's possible to get the source code of the libraries that we are using if you're curious to see how they work from the inside. We don't really need it for our experiments at the moment. Okay, moving on. Where were we? All right, so we displayed the MAC address. Then, if we are not using the tiny driver, so it says here, if ndef, so if not defined, and this is a preprocessor instruction. So the preprocessor is part of the chain of events that happens when you try to compile and upload an Arduino sketch. One of the first things that happen is for the preprocessor, part of the compiler, to go and find little things, little instructions like these, and depending on what it finds, it will act. In this case, it will see that if the tiny driver has been requested higher up, then this function will not be outputted in the text that will be eventually compiled. So it's going to be left out because this contains calls to functions that are not available with the tiny driver. Otherwise, in our case, we're not using the tiny driver, we're using the full driver, so we're going to list out the local networks that are available and are within range. So list SSI results. A profile is a memory of credentials for connecting to a Wi-Fi network. So we can instruct the Wi-Fi module to remember SSIDs, or network IDs, and passwords and types of security like we did earlier in this sketch, so that when power is supplied again to the module, it can automatically connect. In our case here, we want to clear up all such profiles, and from memory, the CC3000 module can remember up to 6 such profiles, so it can automatically connect to those Wi-Fi networks. So here we delete them all. Next, we're going to try and connect, and that happens here. So now we're going to pass the credentials that we set up earlier to the connect to AP, that's an access point. So connect to an access point using the SSID name we supplied, the password we supplied, and the type of security for this network that it was supplied. And this instruction is going to try and connect the device to the local access point, the Wi-Fi network. And hopefully this is going to succeed. And if it doesn't, it's going to let us know. So if we go through this function successfully, then we're going to get a message out that's connected. While I'm here, I'm just going to explain what this F function does. So you notice we've got println parentheses, then we've got the F function, and inside it we've got a string. So with the capital F function, we are instructing the Arduino to store whatever we have inside the parentheses, in this case it's a string, into flash memory instead of static RAM. So the flash memory is where the Arduino stores your sketch. So this is a part of the sketch is basically unchanging once you upload it to the Arduino. It never changes. So that's why it goes into flash memory. Flash memory is not erased when power on the Arduino is removed. So when you reset or you apply power again to the Arduino, then whatever you've got in it will be remembered. The other nice thing is that we've got a lot more flash memory than we have RAM. So in applications where RAM is important and at a premium, we can instruct the Arduino to store things that don't change, that don't need to be dynamic, into the flash memory. Things that are results of calculations, arithmetic calculations, for example, these are things that are dynamic and these have to be stored in RAM, but anything else doesn't. So this particular string that I've got highlighted never really changes, so it's okay to store in flash instead of RAM. Therefore, we preserve a bit of static RAM for our calculations. Okay, the next thing that happens is we check with the local DHCP server to get connection credentials. So this will give us things like an IP address, a DNS server, a gateway, and so on. So once this call succeeds, then our device will be configured and will be a member of the Wi-Fi network. Then we can display the connection details by calling this local function. Let's have a quick look at that. Right, here it is. So display connection details. We declare these local scope variables. Again, this is an unsigned, that's what the U is for, integer of 32 bits. Right. So IP address, the net mask, gateway, DHCP server IP address, and the DNS server IP address. And we can extract this information by like this. So we call the CC3000, the object that represents the Wi-Fi module, .printip.srev. We pass in the IP address reference, right? And then in this location, memory location, we will end up with the IP address that the DHCP server allocated to the Wi-Fi module, right? And the same thing happens with the remainder of these lines. Okay, where are we up to now? So, we've done the MAC address, delete the profiles, we've done the DHCP and the connection details. All right. Finally, the next thing we do is to try and ping this web location, this URL. So, we first resolve the domain name, the host name, to its IP address by calling the getHostByName function of the CC3000 object. We pass the host address that we want to resolve and a reference to a memory location where we want to store the IP address. So this is hopefully going to resolve this host. If it does, what it means is that the Wi-Fi module can contact a DNS server, so it can do domain name resolution. And this function here is going to print out the IP address of the host, www.adafruit.com, in decimal notation. This function here generate pings. So it will send one ping to the IP address that was resolved earlier, belongs to Adafruit. It's going to send 5 pings to it. And we're going to get replies. So this is an integer, an 8-bit integer as declared. You could declare it as 32-bit as well, depending on how many ping backs you expect. So it's going to contain eventually the number of responses to our ping request. And we'll print those out. Hopefully we send out 5 pings. We should get back 5 responses to those pings. So once all that is done, we will disconnect. from the Wi-Fi network, and this is it. The program ends. We're not doing anything inside the loop apart from waiting for a second. The rest, or the remainder of the sketch, are these helper functions that we saw, some of which we saw earlier. Okay, that's about it. We now have a functional Wi-Fi module that can connect to the internet and can ping remote hosts, can contact domain name servers. In the next demo, we're going to do something useful with it.